This conference will now be recorded.
Okay, so the question which we are trying to understand is what is DevOps? Okay, what is DevOps? Why every organization is behind the DevOps? They want to transform themselves into DevOps. They want to hire DevOps team. They would like to they would like to see all of their engineers should be doing the DevOps or DevOps related stuff. So this is something which is going on from last few years, let's say 5 to 6 years, a lot, right? So and the same questions which we have right now today: what is DevOps? Why it is so important for all of us? So I would like to give you a little bit of statement before we begin discussion. Uh, DevOps is not something which is new actually. It's not something new. The name probably you wanna call it DevOps, but the initiative which we are taking under the DevOps, which we've been doing from last 20-30 years, it's like a gradual improvement. Nothing great we are doing about the DevOps. Okay, so the only thing which which we should focus on it, that like we should change our mindset. We should change our mindset, and the mindset in terms of, let's say, what you've been doing for the software development 20 years before or 30 years before or 10 years before is not something we have to do now also. Change the mindset, change the thinking. Like earlier we used to do something 10 years for the software development. Can we change it? Can we change that what we've been doing from last 20 years, 30 years? Can we change it? And the moment you say yes, we can change it, we should change it, and then you have a reason for changing it. So that is starting point for the DevOps. Okay, so mindset change. For example, if I tell you, let's say you are a developer, and if I say, hey, you've been doing development from last 20 years, but now I will ask you to write a code for the testing the product also. Can you write it? And if you say no, 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 I would not write it. I will not be involved into that also, because I was doing the development from last 20 years. I will not do that. So that means it's not a DevOps. You are not ready to change your mindset. Can you write a code for the, if you're a QA person and like, hey, can you write, are you ready for the coding for the product? Ready, I'm saying. Forget about that, you know or not know, that's a different thing. If you don't know, you can learn, but if your mindset's allowed. Okay, so if you say no, then you are not DevOps. If you say yes, I can try for it, I would like to try for it, I would like to learn for it, I want to see that what new things can be adopted in the latest software development life cycle. So yes, if you're ready to change your mindset of what you've been doing from last 20 years, 30 years, 10 years, and you are ready to do something different, then you can say your mind is ready for the DevOps, something like that. So that is something which we are going to cover right now. So let's get into the little bit of history to understand the DevOps in the right perspective. So if you look at this, these are the column I have divided. What we used to do in 1990s, what we used to do in 2000, and what we are supposed to do in 2020s onwards. So earlier, where we are running the software, we were running a software in a physical server. Physical servers can be desktop also. Let's say if I ask you, hey, this is the software, this is the prerequisite, these are all the stuff, can you set up from scratch? Scratch means Getting a hardware, operating system, Java, Tomcat, application, database, this, that, all these things. How much time it will take? Maybe you'd say 1 day. After the application is set up, how the people used to consume that application using console, Windows console, Linux console, how you used to deliver the software in a CDs. So I don't know how many of you have used the software in CDs, but I have used a lot in my college time. I used to have more than 400, 500 CDs, which has a software, a lot of software, and plus movies, plus songs. We used to use the CDs. Before CDs, which was we had a floppy disk. I don't know how many of you have used it. And the release cycle for that particular software development, the duration. Let's say Microsoft, MS Office, or Windows, or Adobe System, Photoshop, and all. How much time they used to take for the software development? 1 year. 1 year they used to develop a software which you will install in a desktop. Setup time probably will take from scratch 1 day. You will consume through the console, deliver through the CDs, and the architecture of that particular software was monolithic. Monolithic means every functionality you have in one package itself. Everything is so tightly integrated in one package. You install in one go, remove in one go. If software has a problem, it will not work in one go itself. Everything will not work. And dev model, are you able to see the last rows of this slide? Dev model, all of you?
Yeah. Yeah.
So what are the development model which we used to use it? Waterfall model. So waterfall model was good for releasing the software for the long duration. Waterfall model, what we used to do? Let's discuss everything in one go, 2 months. After that, let's design everything in one go, 2 months. Then let's develop everything in one go, 3 months. Let's test again after that, 2 months. So that is how it used to take 1 year for the software development. Correct, na? Linear approach. Agree with me?
Yes.
Yeah, Rajesh.
So that we used to do in 1990s. So if you are a pass out for 1990s batch, then you would have a question, why we are learning waterfall model? Why we are learning monolithic? Then at that time also, your senior fellow will tell you, we are following waterfall model. Earlier, before waterfall, hierarchical and network models also were there actually. So before that, before desktop, I think if I'm not wrong, calculator was there, correct? Something like that. Old model of a desktop, and then after before calculator, correct?
Yes.
So then if you ask me why we are learning all this in 1990s, the reasons are very simple. We are following the model and develop architecture and this all these processes because we want to focus on only one thing, and that one thing is having 3 points. Like you want to do some processes, you want to follow some processes, you want to design some policies, principles, tool set, because of you want to improve the quality of the software. You want to release faster as possible. Earlier before Microsoft and all, earlier the software development used to take 5 years, 10 years. I read some of the story in US, the security agency, they used to develop a software, and the duration was like a 10 years, 15 years, 20 years for the aircrafts, and for the software and all stuff like that. 10 years software development. That means today if you start development of the software, it will come out in the market, I mean, for the use after 10 years. So by that time requirement will also change. The world might have changed, right? Don't you think so?
Yeah, exactly.
So Microsoft brought it that yearly model. Adobe brought that yearly model. Let's do the release once in a year. So those people who were doing the software development in 10 years, no, they thought Microsoft is crazy. We are doing in a 10 years of development, and they have decided to 1 year.
ఇంకో చూడు వాయిస్
So this was the reasons why we wanted to. Let me mute, guys. Think. Yeah. So why we wanted to use waterfall model? Because we wanted to improve the quality of release. Immediate release we wanted, and we wanted to reduce the cost reduction in the software development and runtime. So that is the reason we opted for it. But you know what? Suddenly then we got internet. We got internet, and you know that I don't have to teach you what is internet, all stuff like that. You know that. And we started using application not through the console based, but through the browser. Still you are using browser. So which are the application you use through the browser? So if I remember correctly, the first time I used the browser Internet Explorer, and I think I checked the if I'm not wrong, standard 10th marks it. I mean the results of 10th class, I guess I got it access on the internet. That was the first of my experience which I can recall. That for that also I think I paid 50 rupees actually at that time, just for 1 minute. I believe that there were some cafe center near about my house, and then we went to that place and he shared all this information. So yes, now you know that what is a browser, all these things. So we started consuming application on the browser. So consumption had changed. So when it is browser, then that means all the servers, all the application is not running. See, earlier it was running in your desktop. Software was running in your desktop, but now it started running in where? Data center. So when you run in a data center, then they wanted to reduce the software running cost. So they say, hey, if you run the software in the physical server in a data center, that will be very costly. So let's do one thing. Let's migrate to virtual servers. Now I assume all of you know what is a virtual server. What is a VM's virtual server? What is a VMware, vSphere? AWS is also virtual cloud, means where you get a virtual server. Azure also you get a virtual servers. Okay. So in 2000 onwards, we started running application in a virtual server somewhere in data center. But because our application was based in the browser and everyone were using the same applications, so we have to setup time got reduced in the virtual server in 5 minutes. See that transformation. So earlier we used to spend 1 day. Now you are spending only 5 minutes for creating a virtual service. And how we started using application? Consuming browser. How we started delivering the software? Through the downloads and all. What was the release? 2 weeks. So now, how come then you'll say, are we become a very efficient, like the some work we were doing in 1 year, now are we able to do in 2 weeks? No. Still we are doing in 1 year. The work, the one which we are doing in 1990 is 1 year. Today also we are doing in 1 year. But what has happened is, earlier, let's say, we were delivering the 100 of work in 1 year and seeing the failure and success. Now what we are doing, actually we are delivering only 2 works in 2 weeks, something like that, small work. And we see the success or failure. So you immediate feedback, you get it of your code or your functionality, whatever you do, in a lesser span of time. So you release we started releasing once in 2 weeks or 3 weeks. Guys, are you understanding all these changes, transformations, and also like that?
Yeah, yeah, Rajesh.
Rajesh.
Yeah. So now then people say, hey, you want to deliver the product in 2 weeks. Okay, people are consuming the application through the browser. We are running in a virtual server because of cost reduction and all stuff like that. So which architecture of the software should be good for it? Then scientists came and said, hey, don't use the monolithic, because monolithic is like a very heavy. Everything you have to, if you modify even one line of code, you have to build it entire software. You have to test entire software and everything. It's like a long process. let's do one thing. Let's convert into the SOA model. SOA model means service oriented architecture. That means let's keep the web server separate, app server separate, database server separate, and all the components separate, and run it. That is where the SOA become very popular. Still we are using web server, app server, and all stuff like that. Then people say, hey, okay, these are the things which we want, so which model of software development we should follow? Then people say, hey, let's use Agile. Many people got it together in one room, 70 people are in USA, and they said, like, we'll not follow waterfall model, we'll follow Agile, and as part of Agile you should do this, all this stuff. I remember when we have Agile from waterfall, we started migrating from waterfall to Agile. Then I also had the same training, just like you are having a DevOps training now. So we started talking about what is Agile, what is Scrum, what is Kanban, what is this, what is that, how to practice, how to do this, all this thing, all blah blah blah. I'm assuming like little bit of knowledge you have Agile, but if not, just refer some of the quick 5-10 minutes of intros of Agile and you see that. But now 2020s, correct? So this is Agile image. So here, instead of working on too many tasks, we take a task only for 2 weeks. And here what happened in the waterfall model, you know what? All the teams were separate. Look at this. Requirement team were separate, design team were separate, implementation were separate, verification and maintenance were separate team. Different team. See, one objective, one software, multiple team. That's the problem. Okay. So in Agile, what we did, we brought it the developer and testing team together. Earlier, they were working in an isolated environment. But in Agile, we brought it together and say, hey, you work together. So when you work together, then you have a good output, the outcome, which is very good in terms of saving a time, saving a cost and stuff like that, and satisfaction for the end user also. So this is something which we did in Agile. Now, why we migrated to waterfall to Agile? Simple, same reason, guys. You wanted to improve the quality release of quality. Sorry, quality of what is it? Release quality. I got confused here. So quality release or quality of release, and you want to release the software to the market as soon as possible. That's called immediate release. And then again, at that time also, you wanted to reduce the cost reduction of the software development and runtime. So good, Agile, we did it. But suddenly, we know the revolution came. Earlier, we had internet and we were consuming the internet. Nowadays, internet is consuming us. Don't you think so? So nowadays, if you look at this, how you're consuming application, so you have a devices, correct? All of you, and you have a software apps.
Yeah.
You have apps, and you know that. I mean, you are using mobile more than me, so you are pro in that category. So this is something which we are doing right now. Earlier we were using browser, but nowadays look at your daily activities. Whole day you spend on Facebook app, Instagram app. Do you use browser for Facebook? No. App. WhatsApp app. App-based software. Devices. We started using devices. This is your mobile. So if you look at this today's world, everyone is connected together. How? Let me put it in a simple way. You are using the same Facebook what I am using. Think simple. Don't complicate anything in your mind. Nothing is out of the human mind's box. Everything is so easy to understand if we put it in the right context. I'm using the same HDFC Bank what you are using. You are using the same Ola what I am using. We all are using the same software. That means we all are connected to the same ecosystem, same software. So let's say if Ola is down for 5 seconds, what you do? Tell me. what you would do?
Change of application.
You will migrate to Uber. Only 5 seconds. See,
Will
you
very
are not you are not a reliable customer for Ola anymore. Right? So the Ola cannot claim like that I have a very honest, reliable, dedicated customer. They cannot claim it nowadays. Microsoft used to do that earlier. They used to tell, okay, these are our customer base. They are always with us. But Ola cannot say that. Because the 5 minutes, just a 5 second, if you're rushing to the office and if it is Ola is not down, immediately you'll migrate to Uber, or if Uber also not there, locate to the nearest auto and rush to the office, right?
ah,
So now think in terms of development and runtime of Ola. So if Ola has an issue, they have to fix it faster, correct now?
yes.
They have issues, they have to fix it faster. Just because of 5 seconds, they lost you. 5 minutes, they will lost millions people, thousands of people. 5 hours, they'll lose millions of people. And second time also, if it is down, they will lose forever. First time you'll always not go to Ola, you'll go to Uber. Make sense, guys?
Yeah.
So now come back to the mindset of software engineers. Your organization will say Ola. Let's say you are working for Ola. Then the CEO of Ola, I think someone is Bansal, right? I don't remember his name. Yeah. So he will come to you guys, all software engineers, which include engineers, senior engineer, lead architect, all of us, all are engineers. And they'll say, hey, I cannot tolerate this type of downtime. Not even 5 seconds of downtime I'll not tolerate. You do whatever you want, I don't care, but the software should not be down even for milliseconds. So now you as a team will come to the desk and start discussing about it. What should we do? Something different, so the quality of the software we should release should be improved. We should release faster, better, 0% downtime and all. How can you do that? And then you'll come. So each one of you will sit together in one room. Let's say in this room, architect is there, developers are there, Q people are there, operations are there, network guys are there, DB experts are there, and they will share their own expertise, saying that, hey, let's do this, let's design the software like this, let's model the software like this, let's develop a software in a this way. And that is where that these things has come. At that time also you are looking for the quality, cost and speed. Okay, same reason again. In that discussions also you will focus on improving the quality of the software, how to release frequently, and how to reduce the cost reduction and development runtime. So that's a goal right now. We all are having one version of software. There's one Facebook, there's one SDFC, there's one ICICI, there's one Ola. Everyone is connected together 24/7. It should be up and running with a no downtime. So the question is what you should do. What is the outcome in the meeting? So your CEO has come and said, hey, I don't know what you do, I don't care about it, but it should not be, it should be, this is the cost and without any single second of downtime. What you do, I don't care. Now you people will start discussing about it, and then some of you will say, hey, let's do one thing. Let's not run software in a virtual server because it takes 5 minutes. Let's run a software in a containers, which will take 1 second. Let's do the delivery through the app based. Okay, let's keep it in a store. Let's reduce the release cycle from 2 weeks to 1 hour. Maybe I'm just giving you an idea. So Are you thinking you are going to do the work of 1 hour? In 1 hour, you are going to do the work of 2 weeks? No. Your work has been reduced. You are still doing the same work, but your work has been reduced up to the 1 hour. Only you are doing the small work. Are you understanding, all of you?
Yeah, Rajesh. Yeah, Rajesh.
So earlier, let's say in 1 year, when you have released, you are writing 1 million lines of code. When you have a 2 weeks release, you probably writing the 1,000 lines of code. Maybe in 1 hour release, once you have, you're writing maybe 5-10 lines of code. Then you'll say, Rajesh, how come it's possible? So it's possible. That's what we have to learn. Earlier, we were writing the code in a compiled language. Then we migrated to interpreted language. And nowadays, we are writing a code in a declarative language. Anyone have idea about that? What is a declarative language?
No, Rajesh.
No, Rajesh. No,
YAML, JSON,
Rajesh.
XML.
YAML,
Don't you know
YAML.
XML?
Sorry.
Don't you know YAML? Don't you know?
Yeah,
YAML, we know YAML and JSON
Yeah,
also.
that's a declarative language. Just declare it. Work is done. That's all.
Okay.
Correct? So in
Yeah,
Ansible, what you
Rajesh.
do? In Ansible, what you do? In Terraform, you do what you do? Declarative language we use. Jenkins file, what is that? Declarative language. All are declarative language nowadays. You have to do that. Okay. So then many people say, then architect came in the same meeting and said, hey, let's do one thing. Let's change the architecture also, because we have to do all these changes. So let's change the architecture also. Let's run the microservices concept. That means, see, in a monolithic, hundreds of functions where they're assembled together. In SOA, all the service-based architecture, now it's a microservice-based architecture. That means if you have a software which has hundreds of functions, that means there is a hundreds of microservices now. So if you had a 1 million of code, 100 function, now we have one microservices, hardly 1,000 lines of code, and you have to modify each microservices wherever the only problem is there. Not everything you have to test, not everything you have to build, not everything you have to deploy. Only that there is a problem, you do the change and test and deploy within 5 minutes, everything is ready. Make sense, all of you?
yeah, Rajesh.
So earlier monolithic used to do the build 5 hours, SOA maybe 2 hours. In microservice, just 2 minutes, 3 minutes, hardly 1,000 lines of code you deploy in the one microservice, each microservices. So nowadays you see, you might have noticed actually, if you do the shopping on Flipkart, Flipkart is running, everything is working fine, but suddenly you can't see your order book. That means there is a problem only in the order book, that is only down. Rest of the services is still running, so still you can use it, no downtime. And the moment that particular service has a problem, you immediately fix it, release it within a few hours, and no complaint. Are you understanding, all of you?
Yes.
Yeah, Rajesh.
Yeah, Rajesh.
So now the question is, then people started talking about, hey guys, we are changing the everything. We are changing the runtime, we are changing the setup time, we are changing the consumption, software delivery, release cycle, architecture. But there is a problem here. And the problem is all of us. Every people who was attending that meeting, they said, hey, listen, we are planning very big things. But you know what? Our mindsets are not changed. So then one person in the same meeting said, what kind of mindset? So then someone said, hey, can we work together? So in Agile, let me remind you, in Agile development and testing team, we used to work together. But here you required operations also to work together. So someone said, see, this is possible. We can do the release in 1 hour. No problem. But for that, we all have to work together as a team. There should not be multiple team for it. Then they said, okay, I can work together. We can work together. So everyone, no matter whether you're architect, manager, senior engineer, what you're doing, coding, development, testing, operations, infrastructure, DB, network, everyone has to work together, and they started ready for work together. Then one person say, hey, listen, We will work together. That's a very good thing. But are we ready to share the work with each other so I can understand you, you can understand me? So that way there's a less conflict in the team and we can do the delivery very effectively. Okay, can we do that? So then other person said, hey, okay, fine, what you're talking about? So then he said, I am talking about, can we start doing the coding for everything? And we should be ready with the mindset. So something like this, I'm ready. I'm not saying like you have to do that. Ready means ready. I'm ready to code for the product also if opportunity arise. I'm ready to code for the testing the product also if opportunity arise. I'm ready to code for the CICD, operations, security, everything. We all are ready given opportunity. That's important statement. Ready is an important statement. Many people say, no, I won't do that. That's not I have been doing from last 20 years. That is called that you can't change them. You can't. You're still living in the 20s and 90s and stuff like that. Correct, no?
Yeah, Rajesh.
So first
Yeah,
thing,
Rajesh.
can we work together? That's my first question. Can we work together? Development team, architect team, QA team, operations team, everyone work together. We will not communicate through email. We will not communicate through the process and templates. We will communicate through each other, face to face, live, working face to face. When I say that, don't take it like sitting next to each other. Face to face means you and me directly connected for any solving any problems. Okay, directly. I don't need anyone's permission to talk to you or you talk to me. I will directly call you. You can directly call me. I can budge you directly. You can directly budge me. I can ask any questions to you directly. You can ask me any questions to me, and I will cooperate. We'll work together. We'll see the dependency and we'll resolve together as a team. So one team. So it's okay. We all. So in the meeting room, we decided, okay, yeah, we'll do that. We'll work as a team now. Earlier, we were not working as a team. We were working as a multiple team, like a dev team, QA team, ops team. But now we'll work as a one team. And then also we all will evolve, transform into the next level, and we all be ready with a mindset to change, to do the coding for everything. So maybe I'm doing a coding for the product, but if you ask me, I will be ready for the coding for infrastructure, operations, and other thing, CICD also. Same with the operations, same goes with the testing team. That means everyone will become equal, sharing the resources, sharing the responsibility, sharing the work, and teaching, and helping each other. Are you understanding, all of you?
Yes, Rajesh.
Then one person in the meeting said, okay, fine, earlier we used to call it agile team, but now because we have changed a little bit of model of working, then what would you call this model? Then people say, hey, let's do one thing, let's call it a DevOps model. Let's call it this as a DevOps. So what is a DevOps then? The DevOps means, see, nothing changed actually, just mindset. DevOps means you are ready to work together. That's important. When you say together means everyone who's responsible for that software, whether it's an architect, client, development, QA, operations, IT, everyone should be working as a one team, one mindset, and one culture, one process, one practices. Getting your points? That's a concept. DevOps is a mindset. DevOps is a culture built within your family of your software team. Culture of doing something as a team. Are you understanding this?
Yes, Rajesh.
So DevOps is the first mindset. Become one team, not a multiple team. And then second thing, ready for code, ready for automation. Don't say, oh, no, I'm not going to do that. This is not I'm supposed to do. I don't want to do this. This is not a DevOps. Still you are living in the 1990s and all. DevOps means I should ready. See, if don't know, that's okay. That's fair statement. If you don't know, that's very much fair. But if you are not ready, that is the problem. Because if you don't know, you say, hey, Rajesh, I don't know this. Can you teach me? So there is a possibility in a 1 week or 10 days, you'll start doing the same thing which you are not doing. But if you say, I don't want to do, I'm not ready for it, then you can't transform yourself into the next phase of change, right? Correct, no?
Yes, right.
So DevOps is a change. DevOps is a mindset. DevOps is a cultural change in your organization and team, how you work together. And this is called DevOps, guys, in simple way. So the moment you are having the right mindset, you are having the right culture, right mindset inside each individual, right culture in your team, and all of us is coming together to solve the problem of the software, which the CEO said, I don't want even single second of downtime with a certain budget and certain time. So that model is called DevOps. You can call it X, you can call it Y also, but most of the people decided to call this process as a DevOps. So this is DevOps. Make sense, all of you?
Yes,
Yeah,
Rajesh.
Rajesh.
Yeah, Rajesh.
So this meeting went on. So they concluded saying that, hey, we all from now onwards will not call it dev team, QA team, operations team, we will call it a DevOps team. Okay, so naming is done. Then few people started asking questions. Okay, let's do one thing. We are having so much of problems in the software development lifecycle. So much of problems. So much of problems we're having. So how do we deal with it? How do we deal with it? So let's understand the software development life cycle first. I'm not detailing out, but I'm trying my best to put it in a nice way, because these discussions can go very long, but we don't have a sufficient time. So first thing, we do the plan in any software development. And then what we do, after that planning, we do the coding. After the coding, we do the analysis. After the analysis, what we do the build. After the build, what we do, unit testing. After the unit testing, what you do, packaging of software. After the packaging the software, we store the packages, archive the packages. Okay, after the archiving the packages, deploy to QA environment. After that, what we do, after that we perform the acceptance testing. After that, we perform the code coverage. And see that, very simple logic. If all passed, we do the release. If one failed, we do repeat. Correct now? Correct?
Yeah, Rajesh. Yeah, Rajesh.
Yes, Rajesh.
Yeah. So here, which are the two teams are involved? So if I broadly categorize the team involved in this all these phases, okay, planning may be architect, coding may be development, analysis also development, build also development, UT also development, packaging may be operations team or infra app ops team and all, app ops, anything, BR, build and release team, many teams. See, don't get lost in the naming of team. Okay, this is a very complex what slowly will become. Archiving, again, BR team. Okay, deployment to QA, maybe QA team. Maybe here acceptance testing also QA team, and CC also maybe QA team. So these are the things which we do. Different teams are involved here. Okay, what are the different tool sets we are using here? So here, what we are doing, so here for planning probably Jira, for the coding maybe storing in the Git, maybe analysis SonarQube, for build maybe you are using Maven. Okay, maybe you are using Maven. Unit testing, maybe you are using JUnit, maybe Java if it is. Packaging, how you do exe, whatever war file or whatever it is. Archiving, what you do, maybe using Nexus or so Artifactory or something like that. Deploy to QA, what you are using, maybe Ansible, maybe here artificial, I mean acceptance testing, maybe Selenium. Code coverage, maybe Jacoco, maybe Jacoco. Okay, so all this thing tool set. You see what I'm saying? This is one of the popular combination I'm telling you, but you may have any tools actually for the sake of it. Correct now? Problems are same, solutions are many. Make sense?
Yeah.
Yeah, Rajesh.
So now the question is, then people said, hey, can we do one thing? We are losing a time in integration. Okay, we are losing a time in integration. What integration? So there are so many problems between this. See, we all are doing the work very effectively, but there's so many problems between this. Here is a problem. Integration is a problem. Okay, integration is a problem, major problem. So that's where that we lose the time and coordination. So we did the plan, but between the architect and development, there is a gap. Between this, everywhere is a gap. Why there is a gap? Because these are the different teams. So different teams. So that's the reason there is a gap. So many people said, can we fill this gap? So this gap basically introduced some of the wastage actually. So then you will say, what is the wastage you are talking about? So this some of the wastage means waiting waste. Okay, knowledge waste, motion waste, correction waste. All these are the wastage. Then we'll say, what is wastage we are talking about? So waiting waste, and let's put it in simple way. Waiting waste means one team or one individual has completed a work, but he's waiting for something else to deliver the thing. Waiting. Now, if you want to understand this waiting waste, just search in your Outlook, just keyword called waiting, and you'll understand what I'm trying to tell you. If you're working from last 1 year, 2 years or something, search this keyword in your Outlook. You are waiting for permission, you are waiting for code, you are waiting for documents, you are waiting for KT, you are waiting for this, you are waiting for that. That is a problem because of we are having multiple teams. And the knowledge waste. Because of multiple team, we do not share the knowledge with each other. Motion waste. So motion waste means I code committed, but build I'll trigger after 2 hours. Build has completed 5 o'clock, and then we testing team say we'll do that tomorrow because work hour is over now. So 16 hours again motion waste got wasted. 16 hours. So then you must be thinking, am I supposed to? Am I telling you to work for 24 hours? No, you are not supposed to work for more than 8 hours. But your system, sometimes tools can work right offline also. Correct. Motion waste. Correction waste means bug fixing, technical debt. So many wastage are there. So in that meeting, he said, can we avoid this wastage? Then many people felt, yeah, this is a good idea actually. Then what we should do? What we should do? So let's do one thing. Let's set up a CI actually. CI means let's develop a
Continuous integration.
continuous integration. Yes. Let's set up a CI. So what is a CI? So automated build, automated testing, automated feedback for everything. So automated build will happen. So there's no between this and this and this and this, there's no waiting. If the coding is committed, automatically analysis will happen, automatically build will trigger, automatically UT will happen, automatically packaging will happen, automatically archiving will happen, automatically deployment to queue will be done, automatically testing will be triggered, automatically CC will be done. If any of these failures will happen, immediate feedback, and if all pass, release. If one failed, repeat. Between this each of these phases, there should not be even one manual work should be there. Everything should be automated. So what you are supposed to do? You are supposed to write a code for the software. You are supposed to write a code for the testing the software. You are supposed to write a code for the deployment, CICD, and blah blah blah. Everything let it happen automatically. So the moment code is committed, you have results, yes or no. Are you understanding or not, guys?
Yes, Rajesh.
Yeah, Rajesh.
Yeah. So then another person came and said, hey, this is a really good idea. Yeah, we should focus on the real work, not something like a triggering a build, like sending an email or sending update or chatting with someone and giving update. All this thing is not a human work actually. We are designed by the God Brahma for doing some meaningful work, right? Not to do something repetitive work. Else, what will be the difference between the animal and human, right? We should not do the repetitive work. We should automate it. So CI was a good initiative. Then another person in the same team meeting came up and said, hey, let's do one thing, because we are doing very flawless things in the pre-production environment. Can we do the same thing in the production also? That means if the CC is passed, this code coverage is passed, can we deploy the same package to the production also with some checklist and gate and stuff like that in place? Then said, yes, a good idea actually. Yeah. So if you automate it, probably you will be able to release in 5 minutes also. Miss, let's say, just imagine one line of code is done in one microservices, only one microservices. So I don't have to deploy entire software, only one microservices. Development, build, UT, packaging, archive, deployment to QA, acceptance testing, CC, and that code is deployed to the Kubernetes environment in the next 5 minutes in the production if everything is passing. If one is failing, then repeat. But if everything is passing directly, going to the production without any manual interventions. Are you getting my points, guys?
Yeah, Rajesh.
Yes,
So
Yeah,
sir.
that
Rajesh.
process, then people say, hey, let's do one thing. We call it this process where we are integrating pre-production. We call it CI, and then we are integrating pre-production with the production. Then we call it a CD, continuous deployment. Make sense?
Yeah.
So you see that. So again, before going further, I'll just try to recap. What was the problem? The problem was CEO came back to us, all of us. Let's say we all are team, 15 people of team. All of us, they came and said, hey, because of the software problem, we have a very bad image in the market. Our customers we are losing the customers, losses of the company, this, that, and blah, blah. I don't want any bugs in the software. And even though if the bugs is there, it should be deployed, it should be fixed in a few minutes, few hours. I want to run the software with a lesser cost and blah, blah, blah. It should be up and running 24/7. Observability, monitoring, everything should be strong. Then we all came up to the room and started setting up all this problem statement. And we said, hey, we first will change our own mindset. We will start together, working together. Okay, as a team. So first thing, change your mindset. I'm ready to do the coding for everything. Ready. I'm saying don't get scared. Don't get scared for the coding. I'm saying just be ready. Change your mindset. So DevOps is always the first, change your mindset. Say, I'm ready for everything. Second, cultural changes within a team. Then it's not you only, your team also has to be ready, and that's called cultural changes within your software development teams. Third thing, bringing the integration in place. That's called CI. Bring the integration, all this thing integration, integrate everything automatically. No, nothing should be done human dependent. Everything should be automatic. And if you have a successful CI, you should focus on the CD also. So that means everything is highly automated, everything is happening automatically the moment the code is committed, going into the production or repeating the flow should be done. And what we should do as an individual, we should write a code for the software, write a code for the testing the software, write a code for the infrastructure operations, CI/CD, security and monitoring. Make sense, guys?
Yeah.
Yeah, Rajesh.
So now then you will say, someone said, okay, fine, so very good practices we are setting up as a team, but should we change the tool set also? So it will improve our productivity and we can do the things faster. Remember the morning session, what I said? You can do everything with the Java also. But for that, you can use every problem, different problem, different tools. Correct? Right now?
Yes.
So then we started identifying the DevOps tool actually. We started identifying the DevOps tool, what tool we should use. So it will help us to improve our productivity, what tool we should use. And that is where I introduce you some of the tools here. This is the tools which I said, okay, different problem, different tools, we should use it. We should transform into Docker. If you're running in a virtual machine, you should go to the Docker containers. You should use a different tool for observability monitoring. So if there is a problem, which you see the problem, if there is a problem which you may get after 1 month in the production, actually we get a alerts this today only. This is called observability, setup observability. Multiple tools are there: Datadog, Splunk, New Relic, Nagios in the monitoring and all, observability world, infrastructure coding, Terraform, all these things. Okay, so now this is a little old, but there is one set I have created last month because there was some requirement for it, and I would like to share with you. So just give me 2 seconds. I'll share with you this entry. Just let me explain it. So nowadays DevOps is also having different version of DevOps. So nowadays people are talking about the SRE also, DevSecOps also. Right now I'm not including those discussion as part of it, but that's also this is a good discussion. So now the question is how you transform yourself. So someone asked me that my recommendation actually. So typically my recommendation for one of the tools which I'm suggesting right now. So this recommendation I'm labeling as a DevOps certified professional. Okay, this is called DCP. So this design with this selection of tools I made it for that. So if you want to become a DevOps certified professional, DevOps engineer and all, you should focus on these problems and one of these tools. So for example, let's go for the start. So you should know about the architecture, DevOps, SRE, DevSecOps, SOA, microservices and all. You should know about the operating system Linux. You should be very good in one cloud, AWS. You should know one containers tool, Docker. You should know planning tool, Jira and Confluence. You should know one programming language, maybe Python, Flask, some framework or some database. You should be knowing the Git and with the GitHub. You should knowing the SonarQube. You should know Maven and Gradle. You should know Packer and Artifactory. You should know JUnit, Selenium, Jacopo, and JMeter. You should know Ansible. You should know Kubernetes with Helm. You should know Terraform. You should know Jenkins. Should know Datadog. You should know Splunk for log monitoring. You should know New Relic and all. So this is the match tech. Now, if you are only in the operations team, then I think on top of this one, operations team in SRE team, you have to learn this one. You have to learn this one, and on top of that, not learn but also implement in your project. But also on top of that, in the production level, you can go for this training program. Like HTTP, you should know web server. You should know a rancher for the multi-cloud platform. You should know Envoy and Istio for the service mesh. You should know DNS console and all stuff like that. You should know the security related securing the credentials. You should know the infrastructure monitoring team, Prometheus and Grafana, log monitoring, ALK, incident reporting, incident response tools like a PagerDuty and Opsgenie. You should know that production environment scheduler and runbook automation runtime. You should know that app dynamics. So if you're in SRE team alone, you learn the DevOps tool plus all these tools also, it will help you definitely. By the way, there are so many solutions, tools in the market. I'm suggesting this is my preference. Now, if you're in a security domain, so you have to learn all these tools for sure, but you also need to learn the threat models and tools. You need to know all these models. You need to know one DAST tool. You need to know one SCA tool. You need to know one RASP tool. You need to know one WAP tool. You need to know few tools for security credential and all these things. So this is for DevSecOps. So if you really want to align with it, first learn all these tools, become a DevOps engineer. DevOps plus SRE expertise, you get it. This one, DevOps, but into DevSecOps, then additional this one. So finally, what has happened in that room? People decided everything. Okay, we'll transform. We'll change our mindset. We'll learn all these tools, new tools, technology, become one team. We'll work as a team, and we'll have a microservices concept and all stuff like that. Everything and get going. So now, this is something which we are trying to understand, and that's called DevOps. Are you understanding, guys? All of you?
Yeah, Rajesh.
Yes, Rajesh.
Yeah. So guys, this is something which we have to find an answer for it. What is container? If you really want to practice the DevOps, you need to find out the answer for it. What is container? What is microservices? What is DevOps? What is CICD? What is SRE? What is DevSecOps? And if you, not theoretical knowledge actually, try to understand from the practical aspects of it. Theoretical knowledge, big English word will confuse you. Okay? So all this problem has a simple definition. Okay, so these are the complex integration between the multiple team, multiple tools, multiple culture, multiple mindset, multiple processes, multiple practices, multiple SDLC cycles, phases, and bringing all this together and following the DevOps operations. So probably this image is one of the good image. See that no matter what is the tool we have to integrate everything. CI/CD and practice the DevOps. So see here how we are transforming from waterfall model to agile to DevOps. So DevOps is not a model basically, it's a mindset, it's a culture. And then we'll bring the tools along with it. So this is what in simple way I try to help you. So see, tooling part anyways, I think most of you are comfortable. Problems I showed you. This slide is very important. I must have repeated it multiple times. So if you want to take away, change your mindset first, change the culture of team, bring integrations in tools, teams, processes, practices, and then automate everything. Make sense, guys? All of you?
Yes, right.
Yeah, Rajesh. Yeah, we got it.
Yes, Rajesh.
Don't get scared from the coding, because doing a coding in Ansible very easy actually. Don't have to learn 3 months. Just few hours is sufficient. Learning a coding in Terraform is sufficient. Few hours. Okay. So everything is so easy nowadays, and this is how you do the DevOps. Okay, so let me pause this recording for the Q&A session.